Okay, Sally, we're going to talk about saturated acyclic hydrocarbons.
All right.
And ethane first.
All right.
What is the name of this way of projecting things?
Newman projection.
Newman projection, sure. And for ethane, if I put the hydrogens opposite each other at 6 and 12 o'clock, do we call that staggered or eclipsed?
Staggered.
Staggered, okay. But if I turn that conformation through 60 degrees, then it becomes
Eclipsed.
eclipsed. Fine. So this one is,
Staggered.
and this one is
Eclipsed.
eclipsed, and this one is
Kind of staggered.
Yeah, that's staggered. And this one is
Eclipsed.
eclipsed. Good. We plot the energy, knowing that for ethane, the eclipsed form is 12 kilocalories per mole higher in energy than the staggered form. We get a sinusoidal
Curve.
And as we twist that bond between the two CHs, then the energy goes up because of, is it torsional or angle strain?
Torsional.
Torsional,
Yeah.
good. It's the repulsion between electrons in bonds.
Right.
For propane, the torsional interactions are almost the same as for ethane, but there's a bit more steric interaction
Right,
there.
yeah.
And for propane, there's a staggered and an eclipsed conformation, and there's nothing else.
Gotcha.
Now we're talking about 14 kilocalories per mole, a sinusoidal wave interconverting all the conformations. Which one of these represents the most stable conformation? The first one? Because it's eclipsed.
Right.
That CH is eclipsed with this CC. I haven't drawn in the hydrogens in the second one, so it's harder. But is that staggered or eclipsed?
I think it's eclipsed.
It's eclipsed. And this one here,
This is eclipsed too.
this is
Or it's staggered.
staggered,
Okay.
actually. Because that CH is trans-antiperiplanar to that CC.
Already are trans.
Trans and about that bond, and it's symmetrical, so about this bond as well. And how about this one?
This is. Oh, then this is eclipsed.
Eclipsed. Yeah, good. Butane. Butane is a bit more fun
Right.
because in butane we can put the methyls perfectly staggered, or there's an in-between state. Which one of these conformations represents the most stable one of butane?
This one.
Yeah, good. And if we write the Newman projections for butane along the C2-C3 bond, a methyl here and a methyl there, 12 o'clock and 6 o'clock, is that staggered or eclipsed?
This is staggered.
And if I rotate through 60 degrees to the right, does it become staggered or eclipsed?
60 degrees to the right. This is eclipsed, but not fully eclipsed.
Good. Not fully eclipsed, but eclipsed. And if that methyl is getting close to the other methyl, is that a staggered conformation?
No, this is. Actually, yes, this is staggered, but this one, gouge.
Yeah. This is a staggered conformation, but it's not perfectly staggered.
Right.
It's actually gouge.
Right.
Strictly, I think we should just call it gouge. Finally,
This is fully eclipsed.
fully eclipsed because the methyls are close to each other.
Right.
The steric strain is maximum and the torsional strain is maximum. In butane then, the sinusoidal curve in the partially eclipsed form will be what energy, Sally?
Partially eclipsed, 15.
15. Good. And then in the antiperiplanar, it will be
0.
0. In the partially eclipsed form,
14 again.
15.
Sorry, yeah, 15 again.
15 again. And in the gauge form,
4.
4. Now fully eclipsed,
20.
20. Gauge again is...
4.
Now this is important because in organic chemistry, we need to be able to take structures like this and draw them as zigzags. And it's tidiest if we draw them as zigzags in the horizontal plane, or at least the longest chain in the horizontal plane. In zigzag conformations, all the Newman projections along a hydrocarbon chain are totally staggered. The thermodynamic relationship delta G0 equals minus RT line K represents the equilibrium between two states. Imagine a linear hydrocarbon in a fully extended conformation with all the bonds staggered, except one in a totally eclipsed conformation. Well, we know from butane that's worth about 20 kilojoules per mole. We can calculate the population of molecules in that higher energy state. And it comes out to be around about 0.03%. If the higher energy state is a gauche conformation, 4 kilojoules per mole, that works out to around about 20%. Zigzag conformations represent the most populated state of a linear hydrocarbon. That's why organic chemists love to use horizontal zigzags to represent structures of organic compounds. So ethane just becomes a line, and butane is 4 lines. Decane is...
1, 2, 3, 4, 5, 6. I think 2 more.
Yeah, 10. How many carbons in heptane?
7.
And how many in hexane?
6.
And in octane?
8.
Good.